itself is pretty much completely black apart from starlight. But there is starlight all over the sky, and our eyes also become more sensitive. And as a result, we do actually get this sort of hint of noise in our eyes, a bit like digital cameras produce noise, so things can look a bit grainy. We're going to start, however, with a daytime sky rather than a nighttime sky, because I want to make a point in a moment. So here's a nice sunny day in Greenwich, just as it is today, with the Great Equatorial Telescope Dome in front of us. Got Darth Vader over here on the left, and this is Flamsteed House, the original site of the Royal Observatory, and the sun is going down over Flamsteed House. Now, of course, if you know your cardinal directions and the way the sun moves, you'll know that to your right, we're looking to the west, because the sun goes down in the west. So in front of us, we must be looking south. So just bear that in mind, because in a moment I want to spin you around. Try not to get too disorientated. But first, let's just admire the beautiful starry skies as we see them over Greenwich tonight. And, well, at the risk of sounding slightly sarcastic, there are no beautiful, super starry skies over Greenwich tonight, and there never will be again, most likely, because Greenwich is now a borough of London. Now think about this, when the Royal Observatory was founded, light pollution wasn't an issue here on Earth. The biggest issue you had regarding light in the sky was the moon and moonlight polluting the sky. But there was no risk of artificial light on the ground polluting the sky, because in those days, and we are talking the late 17th century here, London was a town across the River Thames, miles away, no electric lights in it, very few artificial lamps outside of people's homes. And as a result, it was extremely dark at night. So you didn't have to go far from London to get to a very remote dark site on a hill here in Greenwich, where you could do, basically, really, really good astronomical observations. But today we suffer from what we call light pollution, and light pollution is all that extraneous light from the 500,000 or so electric street lamps that light up Greater London. That light is shone predominantly down to the road or sideways onto buildings, but a lot of it reflects up into the air. And the air itself, that 60-mile thin film of gas that wraps around the Earth, the atmosphere, is actually a bit like a dull mirror to the ground. And so the lights of London actually bounce off the air, and as a result, we see this dull reflection of London imprinted into the sky. And the light of that reflection is brighter than the light of 100 billion suns from our perspective here on the surface of the Earth. So, unfortunately, the vast majority of the outstanding natural beauty of our galaxy is utterly lost to us here in London today. And we have to get out of London to a rural site in order to experience the sky as our ancestors have for so many tens of thousands of years. Or what we could do is just, in our minds, imagine what it might be like to be here on Easter Day of 1676, when the Royal Observatory was founded and London, like I said, was simply a dark town over the river. Well, in those days, John Flamsteed and Co. would have stood up here on the hill, right where we are now, and looked up at the sky. And yeah, in late April, they would have seen a sky that looks a little bit more like this. Because this is the real, or as we sadly would too often call it today, the ideal night sky. And this is, I promise you, the night sky that you can find if you are willing to travel to do so. Even here in the UK, there are plenty of rural sites where you can find a sky as beautiful as this. Or you could go abroad. You could go to a country that has a smaller population, or a large country with more remote areas, or even just a small country, but one with a better lighting policy. A lot of Scandinavian countries are very energy efficient, and you can see the Milky Way from some cities in Scandinavia. It's extraordinary. But either way, however you do it, I would encourage you to go and engage with the sky as your ancestors have. I mean, it is part of the human experience to see the stars like this, and I'm worried that there will be people who are born today who will live their entire lives and pass away never getting a chance to see a sky like this, even though human beings have done so since they've been thinking about anything, for that matter. So this is an important part of our kind of shared history, the study of the sky. And you'd be forgiven for losing track of any patterns in the stars that you may once have recognized when you see so many stars in the sky. But you'd also be forgiven for overestimating the number of stars. I always think when I see stars like this, there must be millions of stars visible in the sky, but the reality is there are only about 3,500 stars visible in the night sky, to your eyes at least. The rest of the stars in our galaxy make up this band, this ghost road of light that we call the Milky Way, stretching across the sky, but the individual stars in the Milky Way are not resolved by our eyes because they're too distant and they are too numerous. It's just a cloud of light. But still, some of the very brightest stars do make familiar patterns. Here's one you might recognise. This is a pattern of stars we call the Plough. It's an old-fashioned name, really. The Plough, after a horse-drawn plough, is not a constellation. To show you the difference, the Plough belongs to a constellation, so we need to use some fainter stars to trace out the rest of this character. And in our imaginations, perhaps we too can see the character of the story of legend. This is Callisto. Callisto is the Great Bear. And there she is in the sky, one of the largest constellations, a famous northern constellation. And while Callisto is traditionally portrayed as a Eurasian brown bear, she does have this unusually long tail, and that's because of the story of how she came to be in the sky, which involved stretching out her tail. But we don't need to worry about the fainter stars in the Great Bear, because the Plough acts as a separate pattern known as an asterism, and an asterism is kind of like a signpost in the sky. The Plough is a great signpost. It contains two stars that are really helpful. Actually, we collectively call these stars the pointers. And true to their name, if you trace a line between these two stars, they do indeed point the way to something of great interest. They point the way to another star, but not just any star. This is one of the most significant stars in the sky, and astronomers call this one Polaris. And most of us simply call this the Pole Star, or the North Star. Those are, after all, its nicknames. The North Star because, if I put on the compass points, we are indeed facing true north when we face Polaris. The Pole Star because this star is indeed right above the Earth's North Pole, so as the Earth turns around in space, all of the stars appear to trace circles around Polaris, it being the one star whose position is not affected by the time. This star is here day or night in this spot on every day and every night of the year. So we can always reliably find north using the Plough, using Polaris. And this gives us a great starting point as stargazers. We don't need to get a compass out to figure out which way we're facing, but I can tell you this much, most stargazers, after they've found Polaris, they actually tend to spin around and face the other way. So you find north and then you put north behind you, because really it's looking south where we find a more interesting and certainly more seasonal sky. Also in the south we find the moon and the planets, the path of the ecliptic, which passes through the constellations of the zodiac or zodiacal constellations, and we're going to look at some of those today. So sure enough, if we look south tonight, the time on the clock is coming up for 10:30 this evening, we are looking at a typical spring sky. Typical to me from my memory of what the spring stars are, and typical to you, I hope, by the end of this presentation, because I want to show you how the sky is changing. You see, as the night goes on, and indeed as the weeks and months go by, everything which is here will end up down here, and everything which is here will end up here. Things are rising in the east and setting in the west across the night, but also across the season. So over in the west, we actually find remnants of the winter sky. We've got the Pleiades right on the horizon here in the northwest, and we've got Betelgeuse, the shoulder of Orion here, just setting down towards the horizon. The last of the winter zodiacal constellations is Gemini. Here are the twins of Gemini, Castor and Pollux, and again, they are getting lower into the west. The spring sky then is taking pride of place in the south, but the summer sky is beginning to emerge in the east as well. So let's take a look at some of these spring stars. In fact, we can find and identify high up in the south one of the most famous constellations of all, and this itself acts as a great signpost for the spring sky. It's found beneath the Great Bear, so here is the tail and the back of the Great Bear, the bear's back legs, front legs, and head. If we come south, we find this bent out of shape coat hanger. This looks like a small creature lurking underneath the Great Bear. And in fact, it is a creature, but it's not that small. This is a creature that has been independently identified by numerous cultures all over the Northern Hemisphere for thousands of years in this particular pattern of stars, because this is one of the most widely distributed mammals in the history of life on Earth in the Northern Hemisphere. This is Leo the lion. Our ancestors lived around and among and feared and respected wild lions all over the Northern Hemisphere. Lions used to roam wild right here in what we now call Greenwich Park, and as a result, human beings have depicted lions in the sky separately, even with no communication with one another, using this pattern of stars. We generally take Leo the lion to be connected to the story of the Nemean lion. The Nemean lion is a Greek story of legend in which Hercules had to kill a lion that was terrorizing a village at the base of a mountain. In one version of the story, he breaks the lion's neck. In another version, he breaks the lion's back. And because the lion's hide was impenetrable to Hercules' weapons, in the third version of the story, he has to use the lion's own claws to cut it open. And none of those stories are likely to be adapted by Disney anytime soon. But this is the kind of storytelling that our ancestors enjoyed when looking at the stars. To astronomers, though, Leo is a beautiful, bright constellation in the spring sky. Again, as stargazers, we can pick it apart into a couple of smaller pieces. Here we have a triangle representing Leo's tail, and here we have a sort of backwards question mark, or the sickle, as we often call it, representing Leo's head and Leo's kind of chest. And so, if we take a look at some of the brighter stars, we might find something interesting in this constellation. The base of the sickle is the brightest star in Leo, officially, Alpha Leonis. This star is called Regulus. Regulus is actually quite an interesting star because it's a blue-white star, and you can just get a hint of that by looking at it with your own eyes. It's a few times larger than the Sun, and it is much hotter than the Sun. But a more interesting star in Leo, in my opinion, would be Algeba, or Gamma Leonis, which is right here. Gamma Leonis, well, it looks like an ordinary pale yellow or golden star in the sky. But if you have your own telescope, this is one of the best stars in the spring sky to explore. Because with the telescope and with the planetarium space travel, you can get a closer look at this star. Now, it's about 130 light years away, and when you zoom in on it, it turns out this is two stars. Not one, but a pair of stars bound together by their mutual gravity, forming a binary system. Such systems are not uncommon in the Milky Way. It's actually quite strange that the Sun has no companion at all. Many stars do buddy up. And these two, what makes this such an aesthetically pleasing double star is that they are quite similar in brightness and quite close together. When you separate the two components of a double star, something that astronomers call splitting, you can then start to identify which one is the primary and which one's the companion. So the primary is the brighter one and the companion is the fainter one. The brighter one here is a little bit more golden yellow in colour because its surface temperature is cooler than the companion, which is a hotter yellow-white star. The golden yellow star here is quite similar in temperature to the Sun, and this hotter one here, is a few hundred degrees to 1,000 degrees or so warmer. But these are both somewhat sun-like stars. Other stars that are very cool appear orange, and stars which are very hot, like Regulus, appear blue. Leo isn't just a pattern of stars. Any constellation, by definition, is also a window into the universe beyond. So when we look at things outside of the galaxy, we consider them to be inside of a constellation. They're not stars, but they belong to the boundary of the constellation. All the constellations, by the way, have been given boundaries, and I can give you an idea of what those look like. So anything which fits into this irregular-looking shape here is considered to be part of Leo, the lion, even though it's not necessarily that close to the core stars that make up the lion picture as we see it in the sky. And that means that behind Leo's back paws here, we have a lovely deep sky object. And this one gives you great bang for buck because it's not actually one object at all, it's three. We call this the Leo triplet. And these are not stars, they're not nebulae. They are three separate galaxies, which you can find right behind Leo's back paw quite easily, even with your own telescope binoculars at home. Now, they look like faint smudges of light through your binoculars. They can be extremely difficult to see until you kind of avert your vision and look slightly to one side of them. We do, after all, have a blind spot in our eyes at night, so it helps to look slightly away from the thing you want to see to make it appear brighter to your vision. And these three galaxies are fantastic because they're all very similar to the Milky Way. Spiral-type galaxies, but seen at different orientations, showing off spiral arms and also showing off that edge-on effect. where the full spiral structure is seen in silhouette against the core of the galaxy here. These galaxies are millions of light years away. We look millions or tens even of millions of years back in time to see them. And that is really a deep thought. Yes, they appear as smudges of light to our eyes, but